In this video, I'm going to introduce you to thinking about how you teach and some of the models of learning that I employ when designing this course. I'll also discuss some very basic classroom management skills you'll need to develop, as well as approaches to teaching inclusively that you'll need to employ while teaching. I'll also touch on what will probably be something new to you, teaching your students how to think about lab safety. This video is intended to be an introduction to these topics. Additional readings are provided on the General Chemistry TA training site on Canvas for you to read during orientation. You are expected to spend some time in the coming weeks thinking about how you're going to teach your lab sections and apply the information that we discuss in TA orientation to your teaching. Most of us grew up with a teacher standing in front of the classroom dictating what we need to learn. Then, as if by magic, all of the information is imparted in whole and intact into our minds as exactly how the instructor intended it. We also know from experience that this doesn't work. We have questions for our instructor, we don't remember things that the instructor says, or worse, we didn't write it down. We misunderstand things, develop misconceptions, and as students, get questions wrong on the exam. This idea of a sage on the stage model of learning has been shown to be ineffective in describing how people learn. So, to become more effective teachers, we have to think about how people learn. In fact, there's an amazing and short free text called How People Learn, published by the National Academies Press. So how do people learn if the knowledge doesn't magically appear in their brain? Well, first you need to think about how information is processed. Our brains can only sense between 3 and 7 units of information in 1/2 to 3 seconds. Think about that. Right now, you're watching a video, aware of your computer, aware of the lighting in the room that you're in. You're listening to me talk. That's right there is 4 things already. Who knows what else you've got going on around you? Your conscious and unconscious brain is taking that information in and sorting through it in 1/2 to 3 seconds. So information is either grabbing our attention and moved to working memory, or it's going to be forgotten. As instructors, we have to help students sift through that sensory information to grab onto the content that we're trying to teach them so that it can be moved into their working memory. With any luck, the information will remain in their working memory from somewhere between 5 to 15 seconds before it's either transferred over to their long-term memory or it has become forgotten. So how can we ensure that the information is moved from our working memory to the long-term memory? The key here is practice. Rehearsal and continual maintenance use of information will help move it into long-term memory. So the more you have to recall or retrieve that information from your long-term memory, the more likely it is that you're going to remember it. So how do we get knowledge from that information that our brain grabbed up? I use the constructivist model of learning because it provides for me a bit of an explanation here. This model focuses on students having to construct their own knowledge. That's going into that information processing model and saying, look, students like you right there in your working memory, you've got to do something with that knowledge. And the student's attention has to be grabbed. The students has to work with that information so that it's moved to their long-term storage. It requires the students to be active in the learning process and not following that method of osmosis of learning by falling asleep on their textbook. In this model, the teacher is viewed as a facilitator of the student's learning. They are an advisor or a mentor. They are not the sage on the stage, simply there to wave a wand and learning magically happens. So if we take a little bit deeper look at the constructivist model of learning, students have to first engage with an experience. It allows them to perform something, weirdly enough, like a chemistry lab. Once they have performed that thing, say a titration, they need to share that information, their results, their observations, the reactions that occurred publicly. Not just simply think about it. This reflection we have students do oftentimes in a post-lab by writing a lab report or doing their data analysis. This gives the students the opportunity to process their experience through discussion and analyzing information and reflecting on what happened. We want our students to start making connections with those real-world examples and see where they can apply that knowledge into a new and slightly different experience through the form of practice. Hopefully this is sounding a lot like your experiences with working in labs, doing your own lab experiments, writing lab reports, writing journal articles for publication, talking with your colleagues and your lab mates. So now your job as the instructor, you're no longer the student, you're now an instructor, is to take the labs that we do each semester and help guide our students through these steps. Remember, the key word here is guide. You aren't here to show off your knowledge to the students. Your job is to help them gain knowledge through their own experiences. Classroom management simply is not a topic just for K-12 teachers. It's an issue faced by every university instructor, teaching assistant, and anyone who finds themselves leading others. Anytime that you have to get up and give a presentation, you need to manage the room. So don't just limit your thinking about this skill to simply teaching. When you're out giving those professionals talks, you have to have a feel for the room. Is your audience paying attention to you? Are they distracted or on their cell phones? Are there people talking in the back of the room? What can you do to get all of those individuals engaged in what you're saying? Many of the skills that you learn teaching can be applied to leading individuals in a professional setting, giving research talks, and applying for jobs. Your students will form their initial judgments of you and your effectiveness as a teacher within the first 5 minutes of your first class period. So it's important that we make everything count. You have to set the tone for the course, both in how you speak and the expectations that you have and I have for students. This will determine whether or not students will happily remain in your course all semester or they'll be constant complaining about you not being fair. You'll need to practice appropriate body language to help students see that you are friendly and approachable while still in charge of the classroom. Both of these are skills that you can apply to your future endeavors and anytime you have to present information in front of an audience. Let's look at two pictures on the right for a minute. Both are of graduated cylinders sitting on the counter. The picture in both cases was taken looking down from above. However, they illustrate two different things. The top one seems to have no focus. You see all of the graduated cylinders lined up, but none of them seem to stick out to you. The bottom picture, however, appears to have more focus. The graduated cylinder in the middle draws your eyes to it immediately. Then you see another one to the left, and then probably you'll move counterclockwise, looking at the rest of the image. It gives a different feeling and tone from the image above. When you teach, you have to establish this tone by focusing in on key aspects of your teaching and the topics that you're presenting. Your ability to manage your students during lab starts on day one. You have to set the tone for your class. Have a plan for how you'll greet your students. This starts at the door when they enter. You'll need to start building a sense of community and openness the second they see you. Say hello to each student when they walk in and make sure to look them in the eye. Smile and watch your body language. You can also start building a sense of curiosity as students move in the room. Don't simply remind students that this is, the general chemistry lab. Help them understand what is exciting and fun about doing chemistry, what you enjoy about it. Why is this topic of interest to them? Loop back and continue to build on this sense of community you started when you greeted your students at the door. Introduce yourself and humanize yourself to the students. Talk briefly about your intellectual journey, especially if you had a bit of a challenge or some kind of humorous story to tell about it. Focus on your students can be successful too. Talk to your students one-on-one as well. They will find you less intimidating the more you speak with them. Make sure that you give students an opportunity to speak with each other as well. Ask them to introduce themselves to one another. You also need to set your expectations for them from day one. Yes, go briefly over the syllabus and necessary course materials. Make sure they write down upcoming due dates for assignments. Tell students how to contact you when, not if, they have questions. Tell them you expect an email from them in the next week with a question, and you're looking forward to responding to them. Set the other expectations of what students will be learning in the lab. They will need to learn from you, from each other, from the textbook, and from their experiences. Yes, they are going to have to teach themselves. When you are clear on day one of what your expectations are, your students will be more successful throughout the semester. What you communicate non-verbally using your body language says more often than what you know. That's especially true for teachers. Your students, before they learn to talk, learn the basics of body language and how to identify a helpful hand from a hurtful one. Think about the time you were speaking with someone and they were hunched over their computer and didn't look up at you. What impression did you get? Did you think they were paying attention, even if they responded to your questions? Did you feel confident and assured that they wanted to help? Or did you feel like you weren't worth their time? Your body language tells students whether or not you are interested in teaching and their learning. Make sure you are standing up straight, your arms are down to your side, or pointing at something important. Avoid having them crossed across your chest. I get it. That one's hard for me. Crossed hands across my chest feels like my natural resting state. All right? So make sure when you're speaking that you're facing your students. Make sure to avoid speaking directly to the whiteboards. Make sure you're making eye contact when speaking, and make sure you speak loudly, slowly, and clearly so everyone can understand you. I get this one too. I speak faster when I'm nervous, and sometimes I get nervous, talk fast, and then start talking quieter. It takes practice speaking in front of a group of people, and the good news is teaching for a semester is a great opportunity for you to practice speaking in front of a group of individuals. When we talk about teaching inclusively, we're talking about including everyone in how we speak and act. It is about embracing the students' diversity in our classrooms. This first means paying attention when we talk about who our students are. Remember back at the beginning of the orientation, I mentioned the vast majority of our students in general chemistry labs are not chemistry majors. This means we cannot assume that they have the same level of interest in chemistry that we do. Spend some time thinking about how to include other majors in how you present information in the course. Then look back at the demographics. How many students are not first-year freshmen? How many of your students work? How many students are first-generation college students? Where are students from? Are they from urban areas or rural areas? Are they from Kentucky or are they from elsewhere? These are just the start of many questions of our students' backgrounds, and we need to think about when we're teaching. First, inclusive teaching is a mindset. It's thinking about how we can move all of our students towards success. For students in our courses, that's about providing lots of structure early on to help our students get started successfully in the course. You'll find that you'll need to email your students one-on-one more to remind them about completing assignments early in the semester. That's structure. As we get closer to the end of the term, we can pull back on these reminders as hopefully students have gotten into their own rhythm for success. Second, the more structure, the better. It helps our weak students know that you are there to support them. The better students already know that, but do like having that bit of reassurance. Reach out to your students who haven't submitted work 2 days before the due date for the first few assignments. It will help your weaker students know that success comes by completing assignments and that the assignments are available to them prior to their due dates. Third, too little structure leaves too many students behind. You'll find that our assignments that are more open-ended are harder for students to complete. While yes, the idea behind the assignments was to make them think a bit deeper, students still want a bit of structure. Make sure that your students know you are there for them to provide guidance, but not the answers. Make sure your students know what time of day you'll be checking your email or answering questions on Piazza so that they know when to expect a response. We aren't here to weed out the weak students. We are here to make sure all of our students know what it takes to be successful in this course and help them get there. So how do you interact with students and make them feel included in their learning? First, use the think, pair, share method in your labs. Pose a question, ask students to think about it, and give your students time to think about the question. That means you have to be comfortable with silence while your students think. It's hard. I know. Count to 10 in your head, maybe 20, depending on the question that you ask. Then ask your students to talk with their lab partner or someone else at their bench to discuss their answers before you call on students to share their response. Don't be afraid to call on students by names, but you do have to know if any of your students have an accommodation where you cannot call on them unless they volunteer. Not sure who to call on? Ask a bench as a whole. So any of the students at the bench could respond, or ask a row of benches. Just remember, don't continually let the same student or students answer all of your questions. That's not inclusive teaching. Find a way to politely let that student know that their enthusiasm is valued, but they need to let others have an opportunity to share their thoughts as well. I'm sure you're thinking, we don't use small group discussion in a lab setting. Think again. When your students work in pairs or talk to one another at their workbench, that's a small group discussion. Don't be afraid to step in when you see one student monopolizing all of the tasks. Speak with your students, see why one student is doing more of the work than the other, and address concerns with students who feel that they don't measure good, for instance. And that's just something that takes practice. Know what your students are doing, because it takes a discussion about preparing for lab if they don't know what they're doing. Or if a student just says they lack confidence, that's where you need to step in and give them some praise. Every chance you get, you've got to counteract students' self-perceptions of learning chemistry. Don't let them continue to think chemistry is hard, impossible, or something they can't do. If you have a story of your own experience overcoming challenges with chemistry and how you were successful, tell them. Remind them it takes practice for their work to get easier. Help them learn skills on how to solve problems. Help them build their study habits. Make sure to counteract your students' fixed mindset thoughts with those that reflect a growth mindset. Your goal here is to help your students see that their intelligence is not fixed. That's something that they've come to the university to mold and change. So they can't get stuck in this mindset where they can't change their thinking. They've got to start thinking that they can change and grow as an individual thinker. Finally, make sure you connect with your students personally. Learn their names and call them by their names. Ask how you should pronounce a student's name if it's necessary. Make sure you are a good role model and use students' preferred pronouns. This probably means paying attention to their emails and how they speak in referring to themselves. If you're not sure, just use a plural pronoun, which are gender neutral. You can also send your students a quick note to say that you're happy that they're successful, or that there's some things that you're available to help them with when they're not successful. Do so on an individual basis and not as a blast email to your whole class. You want to make sure that you keep individual students' performance private, following the Federal Education Rights to Privacy Act, or FERPA. At the same time, you do need to acknowledge hard times and how grateful you are how your students are handling them. Whether that's through learning new concepts or having a rough week on an exam, or you just simply get the sense somewhere that your students are feeling overwhelmed. If you're paying attention throughout the semester, you'll probably find that I'll be modeling some of these behaviors to help guide you in how to implement them. We know as experienced chemists that our behaviors in the lab and our knowledge of chemicals we are working with has an effect on our safety and our health in the lab. Our students do not have a wealth of knowledge of the materials that they are working with, so it's our job to teach them basic laboratory safety. As you think about your teaching, you also need to consider how you're going to teach your students how to work safely in the lab. To help build your knowledge and your students' knowledge of lab safety, the American Chemical Society developed the RAMP method to help guide your thinking and that of your students in regard to risk assessment and lab safety. RAMP stands for Recognize Hazards, Assess the Risk of Hazards, Minimize Risk of Hazards, and Prepare for Emergencies. We want to build a strong safety-conscious culture in the general chemistry program that hopefully grows into other programs and back into your research labs. So, first you have to help your students recognize the hazards in the labs. This means going over the safety basics and rules, such as wearing goggles, gloves, and appropriate attire, and enforcing it. You also need to review the SDS sheets so that you can highlight to your students specific hazards when working with the chemicals that we're working with each week. Is there something that your students are working with that's corrosive? Let them know, and let them know what to expect if they get some on themselves. You'll also need to help your students assess their risks. Is that corrosive solution very concentrated or more dilute? Have a look sometime at the SDS sheet of water or some other substance you're very familiar with. Then look at the SDS for sodium hydroxide. What's the similarities and differences? How are the risks of using one or the other, the different or the same? And use that information to start assessing the risks of some of the stuff that we're working with. Provide your students information on how they can minimize their risk. Remind them that they need to label solutions so they don't get confused. Have your students wear their gloves and reinforce goggle wearing and appropriate shoes from day one. Train your students on how to properly use equipment and watch them to assure that those standard operating procedures are being followed. Lastly, spend some time thinking about and writing out a plan for yourself in case a student or yourself gets injured. How will you respond? What do you need to do? Who do you need to call? How will that person respond? How do you supervise the injured student and continue working with your other students in the lab? To ensure that your lab runs smoothly and the emergency is responded to appropriately, you need to have a plan in place so you know what to do. So hopefully you've noticed by now in this series of videos that I'm trying to set the tone for my expectations for you, the teaching assistant. I expect for you to start applying what you've learned in this and in the other modules to your teaching this semester and beyond. We will be looking for you to apply this knowledge when we start on our midterm teaching evaluations. And remember, if you have any questions, please make sure to talk to some of